Hey guys, this is lesson 21, the Aldol Reactions. This is what we went over in class, so it should make a little bit of sense. And basically, I'm going to start by drawing my pentane ring. So 5 carbons. You're going to start with what you know. At the 2 position, we're going to have the double bond specified by the En. So I'll make this my 1, and then 2 going to 3 will be my double bond. It ends in L, so I know it's an aldehyde, so I'll add my double bonded oxygen, switch back to carbon, and then I see we have a methyl at the 2 position. So 1, 2, put it right here. Lastly, we want a Z conformation, so we want the highest priorities on the same side. Okay, I'm at work, so I might have to leave, but let's try to finish this. Hopefully they don't need me. I'm going to move this down because I want the same ones on the same side. Roll it around. And I think that should be good. I don't really want to do any double checking except for making sure that my carbons have the 4 bonds that they should have. No more and no less. Okay, here's another drawing one. So I'm going to start with what I know. Pent, so 5 carbons again. See, we have a double bond specified by the En at the 3 position. 1, 2, 3. We have a ketone, so at the 2 position, we're going to have that oxygen double bonded. But first, before I switch, I'm going to add my methyl at the 4 position. So we already specified this is 1, 2, 3, 4. Add my methyl, and then I'll switch to oxygen and add my ketone at the 2. It doesn't specify any configurations, so we should be good like this. And yeah, there's no EZ as you can see because these are the same priority. So there wouldn't be an E or Z. Okay, condensation product of cyclopentanone. So I'm going to start by drawing pentane. Actually, it's a ring, so I'm going to bond the last one over here like this. Arrange, and then its own, so I know there's going to be a oxygen there. And then since it doesn't give me another one, I'm going to be reacting it with itself. So I'm going to add another one over here, and then my ketone. Add my hydrogens, hit arrange, fit, and let's move some things around. And what we learned in class was we're going to go to one of our alpha carbons and take that has 2 alpha hydrogens. So if there's a double bond here, this would only have 1, so we wouldn't be able to do it. In this case, we can use either one. And then we're going to attach at this point, double bond, and then remove this oxygen. So let me show you guys. I'm going to take this bond, and then we can go ahead and try to make that into a water molecule. Just to do it, I'm going to go ahead and delete my water. Okay, and this is what we get at the end. I can't do E or Z because there's no E or Z configuration because this is the same. So I'm gonna leave it like this and see what happens. So what I just did was remove this double bond and then add it, or the double bond that was there like on the same molecule. Condensation product of nonane 2,8-dione. So I'm going to get 1, 2, 3, 4, 5, 6, 7, 8, 9. Bond them up. Okay, dione, nonane. So I'm gonna have two ketones. That's why I have di in front of one. One at the 2 position over here, and one at the 8 position right over here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and this is going to be an intramolecular reaction. So instead of doing 2 of the same products, we already have 2 ketones, so we can just react with each other to make a ring. Okay, so I'm gonna use my heterolytic function, and I've got my alpha carbons here. I also have some alpha carbons out here. But I want to make a 5 or 6 member ring. So if I attach this one to this one, I will get 1, 2, 3, 4, 5. Sorry, hold on. Okay, using my heterolytic function, so I counted 1, 2, 3, 4, 5, 6. Sorry guys, I'm doing this at work and sometimes they need me. And I'm gonna just go ahead and delete. So I took both of these off of carbon, and they can then go and get attached to this oxygen to create the condensation product. Condensation, we know, creates water, but I'm just gonna delete them. We already know the theory behind it. Let's see what kind of ring I got. I got a 6-member ring. 1, 2, 3, 4, 5, 6. Okay. Lastly, I like to move some things around. You don't necessarily have to do that. I just like to do it to make it look a little bit better. Okay, this looks good. And I'm gonna leave it like that. 1, 2, 3, 4. I'm just checking my bonds. Okay, I think all the carbons look decent. Okay, draw the aldol product of 2-methylpropanol. So I'm going to draw my propane. It's going to have an aldehyde at the end and a methyl at the 2 position. So counting from here, 1, 2, my methyl, and then it's only 3. Wrong one, but I can work with that. So I'm going to have 2. Oops. And let me roll it so I can see if I double bonded it. No, I didn't. So I've actually I haven't gotten a question where it says that aldol product of 2-methylpropanol, so I'm just going to try it out and see if I can try to finagle something. So I'm going to take, let's see. I don't have an alpha carbon on either of these. So this one is going to be tricky for me because I don't know what to do. Let's see what I can figure something out. What is it? Aldol product. I would go back and read in my book, but it would just be too long of a video. I'm just trying to look up at what happens in aldol condensation. I don't know what aldol condensation is. Okay, so it looks like you're only able to, since you don't have 2 carbons, you can't do that double bond. So let's see, I'm going to use this one to attach here. That's going to give this carbon 5, and I can't have that. So I'm going to go ahead and grab that hydrogen to make it an OH, or hydroxy group. I believe this is an aldol condensation, but we will see the true results when I press submit. I just want to make sure all my carbons look good. So if I get it wrong, I know that it's not due to my carbons. It's awesome. So when you have 2 alpha carbons but not 2 alpha hydrogens, you can't do the double bonding. So you're just gonna have to make the one you bonded to, an OH group, and leave it at that. Hi, we have hydroxy at the 3 position, 1, 2, 3. We've got aldehyde. I'm gonna add my hydrogens, hit arrange. So this is actually a product of an aldol condensation. Okay, I'm gonna check my chiral center. So I have it right over here, and I've got my first priority down here because oxygen beats carbon. 1, 2, 3, S, counterclockwise. So this should be good as well. Or not. Let's see where I went wrong. 1, 2, 3, 4. Ooh, I put it at the 2 position, so watch out. This hydroxy group needs to be right here. So we're counting from the aldehyde group. Addition product of propanal. So propane. I'm going to change some of the things to oxygen. So sometimes when you get comfortable, you kind of miss key points like that. Simple counting. This is, let's see, we've got 2 of alpha carbons. So I'm going to go ahead and use this one to attach here. And I believe an addition product is just what it sounds like. It's the addition without the elimination. So normally we would eliminate the oxygen, but we're actually just going to leave it like this, kind of like an aldol condensation, I believe. Let's see, I'm either right or really wrong. I'm going to leave it and see what happens. Okay. Okay, bute, so 4. I'm going to make sure to count this time. Let me add my aldehyde so I know what's not fluorine. So this can be a 1 position. I have this. 1, 2. I'll have a double bond. 2 going to 3. And then I'll add my hydrogens, hit arrange and fit. And then I'm looking for that E conformation, highest priorities on the opposite sides. It looks like that is right. I'm going to leave it like that. Awesome. Addition product of ethanol, so 2 carbons. Oxygen, double bonded, oxygen, double bonded. Add my hydrogens. Move this to the side a little bit. And we're just doing an addition. So I'm going to take from this one and attach here, and then I'm going to remove this and attach the hydrogen. This is the addition product. Elimination, we would also go ahead and just remove this and create a double bond between these 2. But we can leave it like this. Just scanning for my carbons. Okay, this is a long name, but we'll start with what we know. So heptane. it's 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. I'm gonna start bonding everything. And let's see. I'll add my methyl at the 4, so I'm gonna count backwards. So 1, 2, 3, 4. I'm gonna switch to my oxygen. I have an ketone at the 3 position down here. Okay, so I'm done with all of this. At the 5 position, I have a hydroxy. So 1, 2, 3, 4, 5. Single bonded oxygen. And then 5 ethyl. So I'll also have an ethyl right over here where that hydroxy is. I'm going to add my hydrogens. And then I'm going to look for the chiral center because it does specify S. If you see me rolling it around, it's because I found it right over here. So we go out one, we both hit carbon, and then we go out another one, and I hit oxygen twice on this side, so it's going to be the first priority. Second, third, it's going counterclockwise, so this is indeed S. I'm going to leave it like this. There shouldn't be any missing like bonds to carbon because all I did was add my hydrogens. I didn't move anything around. So I have my ketone at 3 position, methyl at the 4 position, hydroxy at the 5th position, ethyl at the 5th position, and then finish off by that chain. Let's see if that's right. Awesome. I believe that was it. So the one that I got wrong, just remember, keep an eye on the numbers and you should be good. But yeah, good luck guys.